Hello and welcome back to the channel. Today we'll be discussing the second practice problem on sorting, which is Leetcode question 853, car fleet. The problem statement states that there are n cars starting from different starting points ahead of the zero mark. Each car has a different speed. The speed and starting position of a car is given in the form of two arrays, speed and position. If a car is faster than the car ahead, it will catch up with the car ahead and both will start moving with the speed of the slower car. Similarly, this group might catch up with a group ahead or a group behind might catch up with them. And all of these cars will start moving together. And these groups have been called fleet in this question. So all cars traveling together form one fleet. Now each car is trying to reach a target whose value is given and cars can catch up before or at the target mark to become one fleet. So we need to find the number of fleets that eventually reach the target. Now there are two very important things to understand here. First, a car's speed can only remain the same or decrease. It will never increase. So let's see how. A car might not reach any other car and no car from behind reaches this car. In this case, the speed remains the same. Now if a faster fleet or car catches up with this car from behind, they will start moving with the speed of this car because this is the slower car. And third case is that it catches up with a slower car in the front. In that case, the speed of the car will decrease to the speed of the car ahead. So it only decreases or remains the same. Second observation is that a car behind cannot reach the target before a car ahead of it. So this is a little obvious. A car behind can form a fleet with the car ahead and reach together. It cannot cross any car ahead. Now these 2 points imply that the car whose starting point is farthest from the zero mark, or if we sort the cars by position, then the last car in the array will reach the target first and with its original speed. Now one additional thing to note here is that when we are trying to see if a car will reach the car ahead of it, we will not use speed as a parameter, but we'll be using time. And why is that? Let's see. Let's say that there's a car 2 and there's a car 1 and we have target. Let's say distance between car 1 and target is 10 kilometers and both these cars are 90 kilometer apart. Let's say that the speed of car 1 is 10 kilometer per hour and the speed of car 2 is 20 kilometer per hour. So what would be the condition after 1 hour? After 1 hour, car 1 would have reached the target mark. But the car 2 would have only covered 20 kilometers. So it would have reached somewhere here. It would have covered 20 kilometers and the distance between car 1 and car 2 would have decreased. But car 2 wouldn't have been able to catch up with car 1 and car 1 would have already reached the target. So even though the speed of car 2 was greater than car 1, they did not collide because the distance wasn't enough for car 2 to reach to car 1. On the other hand, let's take a case where 2 was behind 1 and there was a target. The distance between target and 1 was 10 kilometer. Again, distance between 2 and 1 initially was 90 kilometer. Now let's take the speed of car 1 to be 1 kilometer per hour and the speed of car 2 to be 100 kilometer per hour. Now car 2 would take 1 hour to reach the target, while car 1 will take 10 hours to reach the target. So if car 2 is reaching the target in 1 hour and car 1 is reaching the target in 10 hours, definitely car 2 would have collided with car 1 somewhere in between. So somewhere car 2 would have been able to catch up with car 1 and they would have collided. So you can see how speed is not a parameter to decide whether these cars will collide, while time to reach the target is a very good parameter to see if these cars will collide or not. Now let's take a few cars and see what happens or what different options are there or what are the different possible trajectories. So let's start with one car. Let's say that we have a car 1. Let's call it A. So A starts from a starting point and reaches the target. So there's only one possible trajectory. So let's say A reaches the target with speed x. Now let's add one more car behind A. So when we have another car behind A, B, then for B there are two possible options. Either B does not collide with A or B collides with A. So in the case where B collides with A, the trajectories would look something like this, that A reaches the target with X and B reaches the target with Y. In the other option, A and B collide. So in that particular case, the trajectory will be something like this. A will be there, it will be traveling with X till some point. We have the target here, and then we'll be having B. Till this particular point, B will be traveling with Y, and they will collide at this point, and post this point they will be moving together as A comma B as one fleet with a speed X, and they'll reach the target. Now let's say we had 3 cars. Let's add another car behind B. So in that particular case, in the case where B does not collide with A, so in that particular case there will be 2 trajectories possible. So let's take a car C behind B. Now one case is that C collides with B and they both reach the target with speed Y, but they will not collide with A because we know that with speed Y they cannot catch up with car A. And another trajectory possible is that C moves with the speed Z and it cannot catch up with B. Then ABC will reach the target with speeds XYZ and they'll reach separately. So one case is where A reaches the target with X, and then you have B traveling with speed Y till a point, and then you have C traveling with speed Z to a point. They collide here, and from this point they move together with speed Y. Another case is where all these cars reach to the target separately. No car collides. Again, for this particular case, there are 2 options available. A and B are colliding. It could be that C is not able to catch up with AB. So if C is not able to catch up with AB, A and B will reach the target with speed X, and C is not able to catch up with them, so it will reach the target with speed Z. So another possibility is C will collide. So there can be 2 cases in that as well. C collides with B, they start moving with Y, and then they collide with A, they start moving with X. Or another case is A and B have already collided and they're moving with X. Then C comes from behind and collide with this group, and the entire group now starts moving with X. So I'm not drawing all these possibilities, but I hope you've got the notion. So now it might be clear that why we emphasized on those 2 observations, and also why we noted that the last car will always reach the target first. There cannot be any car that will reach the target before the last car, and the speed of the last car will never change. So as we can see that it always makes sense that we start analyzing from the last car and then we keep adding cars to our set while we are analyzing it, because the last car gives us some ground truth. And also another fun thing to notice here is that we just need to compare the time of the car under consideration and the slowest car of the fleet ahead. Because collision or not, the trajectory of the slowest car remains the same. So we just need to compare the time taken for this car with the slowest car ahead. So now that we have established that it is a good idea to start observing cars from the last starting point and moving backwards. So how do we do that? Simple, if we sort the cars based on the position array, if we sort those cars and start picking the car with the farthest position and start moving back in the array, we'll be able to do it. So yes, how we are applying sorting here? By sorting the positions array. So let's go through the code for the problem. So another important concept I would like to add here is that let's say we have a 2D matrix. So we have column 1 and we have column 2. So it's basically a x into 2 matrix. We have 2 columns here. Now when we pass this matrix to our sort method, what sort method does is it sorts all the rows by column 1 and the rows where column 1 has similar value. So there are equals in the column 1. In those cases, to break the collision, it will use column 2 to sort it further. So it always primarily use column 1, and if there are equals, then it uses column 2 to sort those particular rows where column 1 value is equal. So why is it important here is that we've been given 2 arrays, which is position and speed. So now index 0 represents the position and the speed for the same car. Index 1 represents the position and the speed for the same car. Now if we go ahead and sort the array of positions, we'll not have that one-to-one correspondence between position and speed. So we'll not be able to track that the position right now at index x where is the speed for that particular index stored in the speed array. If we combine position and speed into one 2D matrix and then sort it, essentially we'll end up sorting that array by position only, because it will be sorted by column 1 first, but also we'll be maintaining that correspondence because position and speed will be present in one particular row. And in our particular case, it will always be just sorted by position and not by speed, which is column 2, because in our particular case, all the cars will have different starting points. It does not make sense that two cars are starting from the same starting point, because it essentially becomes one car only. Because if they are at the same point, they have collided and they'll move with the same speed only. So essentially, it's only one car. So for us, it will always be sorted by position. So that's what we have done here. We're first defining a 2D matrix with two columns, and in this matrix then we are filling the position and speed values. Then we sort this 2D matrix. Now when we are sorting this 2D matrix, it will obviously be sorted by position. Now the last or the main part of the question is determining how many fleets are going to reach the target. So what we are doing here is we start from the back as we discussed. So we are starting from the second last car because we want to see if the second last car will catch up with the last car. Last car, as we've discussed, will reach the target first. It will reach with the same speed. So we want to start from the second last car, see if it makes a fleet with the last car or not. So, and we are calculating the time taken by the second last car to reach the target. Then we calculate the time taken by the last car to reach the target. Now, if the time taken by the second last car is greater than the time taken by the last car, then obviously these cars will not collide and second last car will reach separately from the last car. They will not form one group or one fleet. So we know that these cars will reach separately. So we have increased the number of fleets by 1. Now in the case where time taken by second last car is less than the last car, they will reach together as one fleet. So we go in the else statement. Now we've already discussed that we only need to compare the time for the slowest car in the fleet and the time for the car under consideration. So why is that? Let's say we had a car A traveling with Y and we had a car B traveling with X. Now they collided and they started to travel with X and then they will reach the target. You can see that the time for car B hasn't changed. The time taken by car B is exactly the same if car A would have collided or not. So now when we are seeing for car C, we only need to compare the time for car B and the time for car C. So if the time for car C and the time for car B is compared and it says that C reaches the target before car B, that implies that C will somehow collide with this group. So we do not need the exact position or the exact coordinates, precise coordinates where they are colliding, or we do not need to take care of the exact trajectory. We just need to make sure that whether they will collide or not. And since the time taken by B is exactly the same, that becomes the ground truth for us. So we just compare the time taken by C and time taken by B. So we want to compare the time for C with time for B. So that's what we've done. In the position and speed array, we have replaced the speed of A with speed of B and position of A with position of B, so that when we reach car C, we are actually comparing the position speed of C with position speed of B. We're not comparing it with A. So we've done this intelligent move to just update the values for car A with the values of car B. Now once we are done with this loop, we'll eventually have the total number of car fleets stored in this particular variable. We'll return this variable from here and we'll have our final answer. So now what is the time complexity for this particular algorithm? So we know that filling this array takes big O of n time and sorting is going to take n log n time. And this particular loop, we are actually just parsing the loop once and we are doing some constant time operations within that parsing. So the entire parsing thing takes big O of n time. So the total time complexity is big O of n log n. I hope this video helped in improving your intuition and understanding of sorting. In case you have any feedback and comments, feel free to drop them in the comment section below. See you in the next video. Till then, take care and keep learning. Bye bye.